And without further ado, Oliver Jewell.
Hi, and thank you very much, Janae, for the introduction and for having me today to give this talk. I hope everyone's keeping well at home. It's definitely been an adjustment for me, and this is going to be my first Zoom presentation. So we'll see. I've practiced with some friends and family, and we'll see if I can manage to do it right. So I think I share screen here. And then I share this screen, and you should be able to see my presentation and not the author notes. Is that right? Janae, are you seeing everything all right?
Looks good to me.
Okay, cool. Well then, without further ado, let's start. So this talk is mostly based around a paper that came out about a year ago. It's the first chapter of my PhD, and it's certainly several years worth of work to put it together, and it has a few background studies as well. But I'll start by thanking my co-authors, and particularly my supervision team, which is Adrian Gleiss here in Perth at Murdoch University at the Harry Butler Institute, Sarah Jorgensen of Monterey Bay Aquarium, and Taylor Chappell, who was at Stanford University, still at Stanford University, but has now moved to Oregon State as well, which is his main affiliation nowadays. And I'm actually going to take a bit of an unusual step and just start the talk by giving you the main result. Now, this might be a little bit jittery because of the connection, but what you're seeing now is a video of a white shark cruising in kelp forest alongside an inter kelp forest in South Africa, near Hans Bay. And it's a seal that just swims along the bottom there. This shark has been encountering seals for about 3 to 5 minutes. This interaction is long, and moving further and further into the kelp forest. A bit of a nudge of some kelp there. And what the seals tend to do when they see the shark is hunker to the seafloor in groups and blow bubbles at the shark. And you're going to see some bubbles right there. And then in response, the shark raises its activity. It swims through the kelp forest, and you might, if you're eagle-eyed, see some seals in a moment. And what was not unusual about this, but nice to confirm, is that some people thought that kelp was a barrier towards sharks and that they wouldn't swim into it. And this kind of proves that they don't do that. There's the seals, if you're eagle-eyed, at the top, and I'm going to go back. And this is the tricky bit. I have to try and time the pause. And there's the bubbles. There's the shark swimming through the kelp forest. And then let's see here, seals around now. And if I get my laser pointer up, there are 3. So there's one here, that's the easiest one to spot. There's another one around here that you'll see as the video plays. And there's a third one here. Sometimes I think I can see a 4th one, and there may even be a 5th one somewhere over here. It's a bit hard to tell for sure. So I just stick with the 3 for now, because I know there's definitely 3 there. Let me just see if I can play again now. I want to unpause the video. Let me get rid of my laser pointer. Yeah, I'll show you again in even slower motion so you can see them. Just look in those areas that I've pointed out. There's definitely 1, 2, 3 seals there. Maybe another one. Anyway, eventually the shark swims so far into the kelp forest that it pulls off its tag and in the trap prematurely, and it's not actually let us know if it caught its dinner that afternoon going into the evening. So it looks like those seals may have escaped it by going to the surface. But what's so interesting about that, I mean, yeah, nobody had seen that from that vantage point before, but what does it mean in terms of predators and their landscape in the greater context of ecology? And every predator adapts to its environment, to its landscape. And I love this example of a lion in the long grass. It's of course got its big teeth and its big claws and great eyesight, but visually, what adapts it to its environment is its coloration. You can see how well camouflaged he is, and covered, which allows him to stalk up on his prey. And our two protagonists, our two predators in this story, are no different. White sharks are quite famous for their coloration of the white underside and the darker top, allowing them to be camouflaged when they're stalking prey from below, and also to try and help countershade them from also being seen by a predator beneath them. But the Cape Fur seal is a top predator in its own right, as this picture from Chris Fallows clearly shows. It's called a blue shark, a similar size blue shark to it, and it is one of the top marine predators of the Southern African ecosystem, coastal ecosystem. And these two play out an interaction that is quite famous, and you've probably seen quite a few pictures of sharks jumping out of the water, often from Chris Fallows and other photographers in that region. And what makes this area so special is that it's between two oceans. To the east, we have the Indian Ocean, which has the warm Gulf current coming through here. And to the west, starting right about here, is the Atlantic Ocean with the cold upwelling Benguela current. And where these two oceans meet, which is around Cape Agulhas, we have mixing occurring, and we have an abundance of nutrients and biodiversity, and we find lots of seals, lots of sharks, we find whales, we find dolphins, penguins, a really, really rich ecosystem in this area, and it's all kind of wind driven. You see the shape of the coastline, and the prevailing summer winds at least are southeast. Against this part of the coastline it blows against, and as the angle changes it blows away, and that's when the wind creates upwelling. When it forces the current away from the coastline, that's when you get nutrient rich and cold water drawn up, and having the warm water meet that cold upwelling water creates that boom in biodiversity. And all along this coastline there are rocky outcrops where the seals have colonized, and I'm just focusing on three of them here because they're three more famous ones for white sharks. We find lots of seals, and therefore the sharks, when they come to feed on the seals, have a really predictable source of prey in time and in space. They know the seals are at those seal colonies, and they know they're going to be coming backwards and forwards between their foraging grounds offshore and their resting area, which is on those islands. It's where they breed, and it's where they raise their young. So if a shark parks itself up at the right time, it's got a good chance of catching its food. And if you're a photographer and you park yourself up at the right time, you have a good chance of getting this kind of picture. So reaching is quite famous, particularly in False Bay. And in False Bay, the right time and place to be is right near the island at dawn. And that's where a lot of these pictures come from, again from Chris Fallows in this Amherst paper. The sharks ambush the seals at the surface, sometimes very close to the seal colony. And we know at False Bay it's at dawn. And some of the research that I was involved in Mossel Bay when I first moved to live in South Africa, discovered that dawn and dusk were the times that would happen in Mossel Bay. And in Mossel Bay, the seal colony is very close to the shoreline. You can actually sit on top of a hotel in Mossel Bay at dawn and into the morning and watch white sharks hunting seals there. But likewise at dusk, you could be at the island and not see many sharks coming towards the end of the day. And then just as the sun goes down, suddenly 2, 3, 4, 5 white sharks will rock up. And again, they're there for the seals. And the theory behind dawn and dusk being the best times is that the light levels are low enough that the seals can't see the sharks coming from below. It's still dark in the water, but there's enough light to light up the silhouettes of the seals if you're looking at them from below. So it gives an advantage to the sharks. And then as the day moves on and you can see deeper down, then that advantage goes, and that's when the sharks stop hunting the seals for that day. Well, I got the opportunity to move from Mossel Bay to Hansby, where I actually had first started working with these animals, and got a chance to move my research. I was working on my master's at that point. And the first thing I thought is we can ask the question, well, where does Hansby fit into this? Does it have more of the dawn and dusk of Mossel Bay, or more of the dawn of False Bay, or something completely different? And so what we did together, myself and my colleague Alison Towner, we started our own tagging and tracking program for white sharks in Hants Bay. And the method that we used was active acoustic telemetry. And what happens here is we put on the back of a white shark an acoustic ping that's maybe this kind of size. And that pings away, and we have a hydrophone on the boat that we use to hear those tags, locate the position of the sharks, and we can also learn the temperature and depth the shark is swimming at as well. But we have to actively follow the shark around as well. So for every one of these positions is us on a boat tracking one of these sharks, and Janae and any of our other former interns could tell you. So it's a lot of work, and for almost 500 hours worth of tracking that we produced in this study, there's probably 3 or 4 times as much time at sea, prepping equipment, tagging the shark, finding the sharks, tagging them, and then tracking them, and also looking for them and finding them, and going home at the end of the day. So quite a lot of effort went into collecting this data. Each one of these positions is at least 5 minutes in duration between them, and each color is a different individual as well. So there's 14 different ones here. And if you just look at it, you can kind of see there's 2 main areas. There's this area inshore, which is called Yabir's Dam. And then there's this spot around the island, which is where the Cape fur seals are. And in general, we used to talk about it as being sort of summertime, the sharks would be inshore, and wintertime, the sharks would be offshore at the island. It's not strictly summer, winter. There would be overlaps in times where they were both at the same area, and some sharks move between the 2 sites as well. So it wasn't just that they would be in one and then the other. But for my master's, at least, what I focused on was this area here. So I'll zoom into there. And I've also changed the map here to show you what it looks like on a rougher day. And so on a rougher day, you can see these white water areas. These are all really shallow rocks and reefs and pinnacles. And there's also lots of kelp forest here as well. So not very safe to take a boat in. And you can kind of make out some of the green there. It's also very thick with kelp forest. So what this picture kind of, I want you to see from it, is that it's a very, very heterogeneous system. False Bay and Mossel Bay are really just rocks and then nothing, then water. Whereas here we have 2 islands, lots of rocks and ridges, and lots of kelp forest, which makes it a very different setting to track sharks in. And the seals, they are all on this island. This one's called Giza Rock, and this one's called Dyer Island. There's lots of penguins on Dyer Island, but there are no seals. The seals all live here. And again, each color is a different shark. Some of them are a little bigger than what it says they are. This one is a very big male called Zane. He had been seen at Dyer Island for many, many years, and a shark that we knew quite well. And I'll just show you his track. He was the first shark that we tagged there. He's an adult male. He's actually probably closer to 5 meters than 4 meters. And what immediately became clear when we started tracking him is that he would stay, and he was tagged right here. He would stay in this very small area of what we call Shark Alley, is a channel between the 2 islands. Stay there all day. And sometimes the smallest I think I recorded was 60 square meters of space for this 5 meter, 1 ton animal, a top predator, to stay in. He was literally staying in that spot the whole time. And the seals, what they do, they have to thermoregulate. They get really hot when they're sitting on the rocks. They jump in the water and they stay relatively shallow, relatively close to the rock. But what he was doing was making these rotations around and trying to grab the seals as they were thermoregulating. And if you got one, he would then take it into the middle of the channel and eat it. And if he didn't, he would just go back around again. And if the seals saw him, they would mob him and kind of chase him away from the rock a bit. But if they didn't, he would have a shot at them, and he would go around and try again and again and again. And even if he ate a seal, he would still stay there. And it was only during the night time that he would actually move away. And this represents 2 days of tracking. This is day 9 and day 10 that we tracked him. We actually lost him at dusk and then found him again just after dark. And on this night, what was different is that we had lots of moonlight. We had a very strong full moon and not very many clouds. And what we saw is he actually patrolled on the offshore edge of this island. It's actually just 2 of us on the boat, myself and my colleague Dickie. And he stayed there until the moon set. And once the moon set, he moved away and did what he did on other nights, which was just swim away from the island, turn around and come back at dawn, and then he moved back into Shark Alley, where it's another day doing what he does during daytime. And his hotspot, this is his movement kernel. And this shows again, red is the hotspot. You can see right around Shark Alley where the seals are, and also this spot over here where he and other large sharks are found very close to some kelp. And that's where we see a lot of the predations in hotspot tend to be in that area. If you're going to see breaching, it happens often around there. And there's some very, very large sharks that you find there in the middle of winter. And at the same time as this study, a colleague of mine was looking at what the seals do. And what she found is that during the summertime, when there's no sharks really around the island, the seals would come and go from their island, their colony, as they please. But as soon as sharks arrived, and it became more dangerous to do that, they started to use these kelp ridges. So this is a big, big kelp forest ridge, and the seals would move along it, and then they would randomize their exit points to their offshore fishing grounds. And so making themselves less predictable, making themselves less easy to catch for the white sharks. And so what the theory behind our findings were, was that the seals are maybe using the surface fronds to break up their silhouettes, thus making it harder for the sharks to spot them and harder for them to ambush them. Meanwhile, the sharks spend a lot of time very close to the kelp forest and sometimes lose the signals close to the kelp forest. So we knew there was something else going on, but at this point we could only theorize because we have surface-based observations of seals and we have surface-based tracking of sharks, and we can't really see what's going on underneath the water. It's not necessarily a great idea to go snorkeling in an area like this where it's A, rough, and B, there's sharks trying to hunt seals. So we needed something else. We needed some solution to really tease apart what's happening under the water with these animals. And the solution was that right towards the end of collecting data and finishing my master's is I was approached by Taylor and Adrian and Sal to start putting these newly developed camera tags on the fins of white sharks. And you can kind of see from this picture how it works and how it fits on. We have a clamp that fits onto the dorsal fin of the shark, and we have a spring that kind of holds it open on the end of a pole. And then this clamp has a magnesium sleeve on it. So this starts to eat away as soon as it's in salt water, and it will last for a week to 10 days or so. And then we have another corrodable clip here. It's called a galvanic time release, or a GTR. And that's an alloy that's cut specifically to be this thick for this long, and it will last for a set number of hours or days or a week or so. And then when that's eaten through, the tag pops off, it releases from the clamp, it comes to the surface, and we'll have a VHF transmitter or a satellite tag to help us find the tag, pick it up, and bring it back to download the data. And then afterwards, then the clamp will go, and then we'll leave nothing on the shark. So great in theory. It's still quite a challenge to get it on the shark, and it looks something like this. So this is Taylor and I tagging a shark in handspike, and what we do is, this is from the shark's perspective. We distract it with a piece of bait, attract it close with some chum, and then as it swims up towards us, we simply fit the clamp to the fin, and the shark swims away, hopefully collecting data for us. Now inside the tag, just as important as the camera are the motion sensors, the biologists that collect data for us. And I'm just going to focus on two of them now. That's the accelerometer and the magnetometer. And I also use depth and video in this paper as well. So I'll focus on those. There's a few other things that TAC does as well. But for this part, all you really need to know is that an accelerometer is triaxial, which means 3 axes, which are X, Y, and Z in this figure. And it's basically a measurement of how the animal moves. Acceleration on surge, heave, and sway, which are your X, Y, and your Z. And papers, Z and Y are sometimes interchangeable depending on your sensor or what animal you're putting it on. And it tells us how they move in 3 dimensions. It's very similar to the technology in your phone. It knows when you twist your phone upright, it's got an upright orientation, and your picture changes as a result of that, or your video, because it's got a triaxial accelerometer in there. And what the magnetometer is pretty much on the same axes, and it's a compass, and it tells us where they move. So if you've got your 3D compass and you've got your 3D movement sensor, you can start to piece together movement steps of the animal in 3 dimensions, which is exactly what we did. And this is an example from my colleague Sami Andriacek's paper on tiger sharks, where she used exactly the same type of tags on tiger sharks. And what she did was create this 3-dimensional plot. It's a deduced reckon plot, a dead reckon plot, or a pseudo plot. And we call it pseudo because we don't really know the exact longitude and latitude on this, but we do know what the movements look like in 3 dimensions. So here you can see there's periods of time where the tiger shark is moving straighter, and there's periods of time where it's more squiggly, or more linear and more tortuous, the movements here. And what she was able to do with the camera is see when the tiger shark was seeing prey, like sea turtles or big fish, and relate that back to when there were more tortuous or less tortuous movements. And so she was able to discern that those more tortuous movements, those are more likely to be when the shark is seeing prey. So more interesting things. What I did with the white shark in the kelp is I used the same type of processing, only I flattened it into 2 dimensions, and I overlaid the track with different colors for when there was and when there was not kelp seen in the video. So the lighter green, that's low density kelp forest, maybe just fringing, or fronds away from the main patches of kelp. And then the darker patches, that's where it's really thick, that's where it's in kelp forest. More than 50% of the frame of the camera is within kelp forest there. And what I've also got on here is moments in the video where we saw contact with the kelp, and moments in the video where we saw seals. And then what I've done over here, all you need to know about oddbuzz is an overall activity. So this is how active the shark is during the same period of time. This is the depth the shark is swimming at during that period of time. And this is how much it's turning. It's turning angles during that time. And just looking at it visually, you can start to see that in areas where the shark is moving straighter, there does tend to be less kelp forest than the areas where it's more tortuous. And the periods of time in kelp forest are repeated. So it's in kelp forest, and it's back in kelp forest, and it's back in kelp forest, and it's in kelp forest for a really long time later in the track. And that's important to know because you were expecting to see the shark repelled by kelp forest, or it wasn't interested in the kelp forest, then you'd see the kelp and then you'd see the shark quite quickly move away from it, rather than what appears to be that it's drawn towards it and it's actively moving towards it into the kelp forest. And then you look for, well, where's it seeing the things that it's interested in? Where's it seeing the seals? And the first seal was seen in kelp forest, but this seal swam straight over the shark's head and disappeared very quickly. And the shark did turn around. You can see it's a 90-degree turn, 180-degree turn, but the seal was good. That shark had no chance with that seal. But later on, and I'm going to zoom into this area up here now, when the shark started to see the seals up here, they were in the same area. And there's groups of, sometimes you see one of them, sometimes you'd see 5 of them. So there's a decent sized group of seals here. And this is where they hunker into the seafloor and they're blowing bubbles. You saw a small section of this in the video. And the shark is moving backwards and forwards over the same area. So what we can tell from this is we don't have the exact spot geographically, but what we can tell is that these seals are in the same spot. The seals aren't moving much, the shark is moving around them. And eventually it picked up its activity, and that was when you saw the seals at the surface, but it didn't manage to catch them. Pretty interesting stuff. Of the 8 sharks that we tagged in this particular season around the island with cameras, we saw 7 of them stay around the island. 1 of them moved away, that's the one with the least kelp. But of the others, they all spent at least some time within kelp forest. And some of these durations were quite long and they were all repeated. So all of the sharks were going into there. We did only see seals from 1 of the sharks, and we did not see whether that shark captured them or not. So even though we're not sure how successful they are in the kelp forest, what we're able to conclude from this is that because there's increased activity, because there's increased turning, and because there's repeated visits, and we know from the other 2 studies that the sharks are spending significant periods of their time by kelp forest, that it is probably a foraging habitat for them. They are probably going in there because there are seals in there. And it's something that we wouldn't have been able to confirm without the new technology. It's something that gives us this unforeseen insight into what the animals are doing, and what the motion sensors allow us to do is to quantify them. And this study has now been published. It is available open access through Biology Letters. If you just Google Biology Letters and white shark kelp, you'll probably find the paper, but I'll also put it in the text of the thread. There's also some great artwork from my colleague Ed, where he made a white shark out of kelp, out of steel, and he's got a blog about that, how he did that and why he did that, which I will also include in the text. And what we're up to next, I know we're going to run out of time in a moment, so we'll probably have to reconnect. But what we're up to next is we're working lots of different landscapes. I've spent the last 3 Californian seasons out at the Fowler Islands, where we're tagging some of the. Okay, so we've got unlimited minutes. Great, thanks, Janae. Where we've got some of the largest white sharks in a really heterogeneous and remote spot. And they're there hunting some of the largest pinnipeds on the planet. They're hunting elephant seals and some adult elephant seals even. So that's an incredible sight. And we've also got, we also tagged sharks. This is my supervisor, Sal Jorgensen. This is off Aptus in the summertime. So coming up soon, you start to see more and more small, really young, really small white sharks hanging around very close to the shore. In Aptus off Santa Cruz, where there's lots of infrastructure, there's lots of people, and there's lots of boating traffic. So we've got some very different landscapes, and we're trying to look to see how all these different landscapes that we've got white sharks aggregating nearby affect how the white sharks do what they do, how they use their activity, and how they choose to try and hunt their prey. So that's about it from me. I would just like to again thank my colleagues and my co-authors, and thank you to all of these organisations, particularly Marine Dynamics and the Dyer Island Conservation Trust. They're the ones who host us in South Africa. They're the companies that I've spent many years working with. CATS, who developed these tags for us, and of course my affiliations, Monterey Bay Aquarium and Murdoch University. And the grants that have also sponsored this work too. Cool. Well, I think that's it for the talk. Janae, do you want to hop in, and then I can end the slideshow. Okay, if we end the slideshow, and do I stop sharing? I have stopped sharing.
let's see what we
Okay.
have for questions.
Right. Yeah. So we're now into talk screen.
Let's see. We've got a question. Is the recording device fixed permanently on the shark when you go out when the shark is around and it just pops up on your monitor, or does it fall off after some weeks or days?
Yeah, no, we're not there yet. So that would be lovely if they could stay on the sharks and we could just upload from a computer. It might be possible one day, but the problem that we're limited by with current technology is you can't send signals from, you can send Bluetooth, but it's a very limited range and it's a very limited bandwidth. You can't send satellite transmissions or radio waves from the water, from beneath the water, from at least a couple of meters up to a satellite or even to a ship to upload. You can send acoustic signals, which is why those acoustic transmitters work well. But for video, we have to get the tag back. So the tags stay on for, the longest we've got is about a week and a bit. After that, they start to run out of battery anyway. And the video, the maximum recording is about 12 hours of footage that we can get from these. But they have to come back. So we write our email addresses on them as well and our phone numbers. And sometimes very nice people find them on shore and give us a call. Other times we're looking, constantly updating our web browsers to see when the satellite tag pings in, and then we can take our boats, we can make a plan, and we can go and get these tags back. Or the radio, the VHF ones, we'll just go to like a nearest hill or mountain in Hansby and sit up there and listen for the tags. We have a rough idea of how long they're going to stay on, but it's never exact, and we just have to kind of be prepared at any moment to go out and try and get them back. Yeah, I hope that answers the question. It's not permanently on the shark.
Hello, I'm Federica from Germany. So hello to South Africa. Hi. Just one question from my side. To me, it looked in the map that the white sharks, something like how do you call it, territorial, so that they stay always at the same places again. So not only on the rocks and the kelp, so as well at the shore as well.
Yeah, that's exactly what you mean. Thank you for your question. So what we've seen, and we don't necessarily think that they're territorial, because we do occasionally see bites from one another, but it's more that they have spots that they like. So they're really site-fidelic to certain spots, and each shark seems to have its core area that it really likes to go to. Like Zane was the shark who was in that really, really small spot. But he wouldn't necessarily be the only shark in it. There would often be other sharks, and other sharks that had slightly different hotspots. The other big shark we got, Slashfin, for instance, he liked just around the other corner of Shark Alley. And we think that because the prey resource is enough, that they're not super territorial, that they won't really chase off too many other sharks. But it might exclude some of the smaller ones. Smaller sharks might be a bit intimidated hanging around larger sharks, but the larger ones tend to be around each other a fair bit in these aggregation sites. There are individuals. They don't, as far as we know, they don't hunt in packs, but they do seem to tolerate each other a bit in these situations. Very occasionally, when you're around a cage diver, but you might see one try and chase off another shark from it, but it's rare. It tends to be more that they have these spots, and they do come back to the spots year after year after year. So they've learned where they want to be, and they stay there for long periods of time, and then they'll migrate, and they migrate actually to Mozambique and the Mozambican Channel. Pretty much all of these bigger sharks did that. So they'll be there for a few months, and then they up and leave, and they make their way to Mozambique.
So yeah, they still move the shore up and down.
They do move up on the shore up and down. It depends on the site where they move, but yeah, we get quite a bit of back and forth movements in those reef systems closer to the shoreline, or down the side, up and down the side of the island, or further off the island. But yeah, you do tend to get fair bit of back and forward movement.
Kind of in that light, we had a question, were any of these sharks, would you consider them residential to the area?
Seasonally residential. So Zane, you could pretty much set your time by him, check your calendar, and from like April, sometimes from March onwards, he would be there, and you'd find him around those same spots that we had the hotspots from. He would be there for about 4 months or so. He would be pretty residential to that area. Same with Slashfin, which was another famous shark from that area. Again, he'd be there for the winter months, and then he would move on. Whereas other sharks would just visit for a few days, maybe a few weeks, and then they'd move to a different spot. So none are permanently resident. Maybe a few of the very young ones in Mossel Bay might over winter and over summer stay within the bounds of Mossel Bay, but most of the sharks are seasonal. So they'll seasonally aggregate where they feed. They'll have a spot somewhere in the aggregation site where they rest as well. And then when they're done with their season, they'll move on to the next spot. So they're not resident, but they're repeat visitors.
Great. We have a question. Was 2019 the first time these video tags were used for these animals?
No, 2019 was when I got around to publishing the paper. So no, our first paper is actually Taylor's paper, Taylor Chappell's paper, and that came out in 2015. We were the first ones to use these tags. So these are customized animal tracking solutions tags, CATS tags. We were the first to use them on white sharks, and we first did it in 2013. But there's another type called a Cryptic that's been around for many years. Alison Koch deployed some of those in False Bay in South Africa, but they were used even before then, even off the Farallands many years ago in the 90s. Those tags were developed, but they couldn't do all of the things that a CATS can do. We also have colleagues in South Australia, Charlie Houveneers, put similar types of tags called Little Leonardos on white sharks off South Australia, and there's various colleagues who do it off of Mexico as well, and even Cape Cod. Taylor's been to Cape Cod, but I believe we're the first ones to put CATS cams on white sharks. They had previously been used on whale sharks and many other species as well, though.
Phoebe says she's heard light pollution from cities affect hunting activities of sharks, so more hunting at night because of more light. And have you noticed trends like this?
Right, so that was in Mossel Bay, at least with white sharks. There was a theory that, and it was in a TV show called Sharkville, that the light pollution from Mossel Bay might allow the sharks to hunt at night. And you don't get much light pollution in South Africa in general, at least in most of these areas. But in Mossel Bay, the Seal Island was very close to the shoreline, and there were lights, there were factories as well. It's quite industrial, that part of Mossel Bay where the Seal Island is. And there could be some potential for that. But most of the hunting occurred during dawn and dusk, so it was more natural light. Could be a factor, and again, that's why I included the slide that had the moonlight, because it definitely seemed like there was an effective moonlight there from that type of tracking where we actually physically have to be on the water. We didn't get enough data, but with these new biologists, we don't have that same kind of limitation. So I can't say for sure about whether light pollution is, but it's an interesting idea, but it's limited to a seal colony that's very close to an industrial town, and of those where there's white sharks, I can only think of Mossel Bay. Even in Cape Cod, it's not the same kind of lights that you would get from Mossel Bay.
Next question. You guys got this amazing footage, first in the world, of watching this white shark go into the kelp forest. Do you know if there's any other footage or evidence of sharks going into other kelp forests and other locations in the world?
Yes, actually, I don't know if there's footage though, that's the thing. But I got contacted when this paper came out because there was anecdotal evidence that they did it. We had seen it. Alison and I, Tauma this is, were tracking a very large white shark, and it spent a whole day swimming through kelp forest in actually the northern part of the bay, not even that close to the seal colony. So we know that they do it, but you can't just say, oh, we saw the sharks swim into the kelp forest. You need to get the footage. And I have seen it. I have physically seen it in Año Nuevo Island in California. But again, we don't have the footage. So it was really the camera tag that helped us to say that this definitely does happen. But I think it tends to happen where there's an interest. So it's not like you're unsafe if you're swimming in kelp forest, and I certainly wouldn't want to say that, have that as a message from this paper. But if you're by a seal colony and there's lots of seals there, and this was the top white shark population in the world at the time, then if there's seals in the kelp forest and the sharks know there's seals in the kelp forest, that's somewhere that they will check out. So yes, but I don't know if there's footage to answer that question.
We got another question asking if you feel like your constant presence is changing the shark's behavior during your data collection.
Yeah, so absolutely. When we are there, we're chumming for the sharks to come up. We use the same methods as cage diving. And yeah, absolutely, you can see. And what I didn't include in that map, I actually cut out our impact. So you can see quite clearly in the original pseudo track, there's circling, and that circling is the shark circling our vessel after we had tagged it, and we could see ourselves as well in the footage. So it basically just cut that bit out. Our influence on them was cut from this data, and you can even hear our boat leave at the very beginning of that track. So yes, the sharks will react to chumming vessels. Sometimes they don't, and sometimes they move away, but we can quantify it because it's a really clear movement signature when they're coming up towards a cage diving boat or a research vessel, and we can account for it. So yeah, to answer, yes, in this area there's cage diving as well, and other sharks we have footage around the cage diving boats. But during this period of time there was not. That was towards the end of the day and we had left the area. But yeah, it's something you have to be aware of as a scientist. If you're tracking wildlife, you have to be aware of what you might be having an impact on. And the great thing is about these tags, they stay on for a longer period of time than we're around, so we can get the natural stuff once they move away.
Mallory wants to make sure she understands that. Are you now doing a similar type of study with that video tag, but on a different type of landscape?
Yes, we are. Together with my colleagues, we've done 3 separate seasons in South Africa, but we've done way more seasons in California now. So California is where I tend to go October, November. This year's crazy. I don't know if I'm going back. I also have to finish my PhD this year as well. But yes, so our research group has taken quite a few different areas, and we are looking to see if they behave differently in different areas. Stay tuned. You can follow me on Twitter or on ResearchGate, and you can look out for our papers as they get published. We'll let you know when we are able to say more about that.
Robin says, great talk, cheers, and asks, do different individuals prefer different bays along the coast? Is there a pattern as to which individuals are seen in False Bay versus Hans Bay, for example?
Yes, absolutely, that definitely happens. And why, we have no idea. For instance, so the famous ones that like Janaina's Slashman, which is what Marine Dynamics' boat is now named after, he would be in Hans Bay every single year. Same with Zane. And these two sharks would never get seen in False Bay or in Mossel Bay, except for 1 year. Slashman didn't show up, and they ID'd him. We saw him on our friend, I think it's Ed, saw him on Facebook in a Facebook picture and said, "That's Slashman." And sure enough, it was the same shark. Whereas other individuals, when I left Mossel Bay, was a bit sad because I've been in Mossel Bay for a year or so and got to know quite a few of those individuals really well. And I was a bit, I was like, I'm going to miss these guys. I counted 5 or 6 sharks in the first month that I knew very well from Mossel Bay and thought they were staying in Mossel Bay were actually present in Hans Bay as well. So they do move up and down, and they can move pretty quickly between sites. Why they do it, and False Bay has its sharks that are never seen anywhere else. Mossel Bay has ones that are never seen anywhere else. And there's a lot of aggregation sites that we don't really know that much about. There's a huge nature reserve called Dehu, and there's lots of white sharks there, and we know a lot of them go there from our satellite tracks, but no one knows really what makes one choose this is where I'm going to hang out versus another. I presume there's been some good experiences there, some good hunting, and it's decided I like this spot. Yeah, I can't probably say more beyond that, other than, and a lot of them move side to side too.
Owen wants to know, given the battery life of the camera is roughly 12 hours, are the clamp systems limiting the track through accidental detachment? They look minimally invasive compared to dart tags.
They're pretty minimally invasive, and they come off quicker, which is great. But the limitation is just that. You covered it in it. They do fall off accidentally sometimes, like our one that swam through the kelp. So and it's a lot of trial and error. If you don't get the positioning of the clamp just right, if it's pointing straight up, and it's got a very good chance it's just going to slip off, because then suddenly the hydrodynamics want to push it off. So yeah, they fall off, and that's the limitation with this one, is that they can. Firstly, they can only stay on for a maximum of 7 days. Secondly, and we get a lot more than the camera. So the camera footage is really useful, but the motion sensors, we get way more information. Those motion sensors can measure at 100 hertz, which is 100 measurements on each axis every second. There's 3 axes, and there's 3 different sensors reading those. So that very quickly becomes gigabytes and gigabytes of data. But there are other forms that you can get a bit longer from. So my supervisor Sal developed one that you could feed to the shark, and it would stay in the stomach for up to 2 weeks, 3 weeks or so. The trouble is then, the longer you keep them on the shark, is where it pops off and how to get it back. And we had one that popped off and it ended up floating all the way to Hawaii before someone found it. So the shark, we don't know if the shark went to Hawaii or not, but the tag certainly did. And that can be a risk. We lost one in Hans Bay that washed up on Cape Town 2 years later. We got it back. And we probably have like 1 or 2 out there somewhere, but we've been, touch wood, we've generally been very lucky with it. You pick your weather window, and if you've got rough weather coming soon, then you'll try and keep it on the shark for a longer period to try and have it on through the storm and then pop off afterwards. If there's a storm coming in a few days, you might go with a shorter duration and try and get it back before the storm. But you're always very nervous when you're waiting for your tag to pop off. I think I went on a bit of a tangent with that question. Sorry about that. It was Rob, right? But yeah, different tags have different strengths and weaknesses. There's no such thing as the perfect tag. So before you tag an animal, and it's the same, it should be the same in any field, you have to first ask yourself, what question do I want to ask? And then that will determine what tag you want to use and how long it's going to need to stay on, how many individuals you need to get. And then you need to take that to an ethics board to get your ethics approved before you go and put an instrument on an animal. So I don't think I really covered that in the talk, but it's important to know that all of this research is permitted, and we set up these questions over a number of years before we tag any individuals.
There's a lot to it, yeah.
Yeah, yeah. It's a long process and like many hours. Like my days right now are spent right here because I'm not allowed to go to an office, as none of us are. I don't think. And I spend many hours with my computer processing this data, trying to make sense of everything that we've got, and then also planning our next trip, where we're going to do it. How much budget we need, and what permits we need, and when are we going to do it. That's something that takes many individuals or a very long time to figure out. So yeah, as any research scientist will tell you, a lot of time is spent right here on the computer, not so much in the field.
Right, Ricky wants to know if you can tell if the kelp inhibited their maneuverability compared to open water, and would that be a more beneficial predation method for them?
That's a great question from Ricky. And certainly it can't swim as freely if there's kelp present as it can when there's not kelp present. And it's not so much the benefit of open water. The sills themselves are also very mobile. And it's that the sills are in the kelp forest that the shark is going in there. You saw in the one slide there was the randomized movements of the sills out of the kelp forest. So once it's out of the kelp forest, it's got loads of space to move into. You have to really be in the right place at the right time if you're a shark to catch them. To know exactly where the sills are at any one time, probably the most likely place is in the kelp forest. So it's about increasing your chance of encountering your prey that drives a predator to be in that spot. And I think that it's probably just a more likely spot to find them is in the kelp forest, and that's why it's a driver for them. And they spend a lot of time right on the edge of the kelp forest as well. On the edge, moving in. As long as you're near the kelp, you're near where the seals are, and that's when I think these sharks in this area have the best chance of catching them. In False Bay, there's no kelp forest. In Mossel Bay, there's no kelp forest. So there, the sharks have to sit in the open water, and then they have to ambush them. And because there's no habitat around those areas, the seals have to go over the same route. So if you park yourself somewhere in the channel of offshore and island, the seals have to pass by you at some point. And that's when you get these predation hotspots where the sharks wait. The big ones that are experienced know exactly where that spot is, and they know exactly the time they need to be there. And they sit there, they wait, and they ambush, and they breach. So I think it's just that this habitat, the island habitat, gives more options to the predator and the prey, and that's why it's moving in there. Yeah, it would be way easier to swim in an open ocean where you don't have to make turns, and you don't have to bash through the kelp, but the shark has absolutely no problem doing that, swimming through the kelp, maneuvering around bits of it and bashing through other bits of it. It's just not a problem for it. It's comfortable there.
Robin says, I've read that there's been a significant reduction in white shark sightings in Hans Bay and False Bay. What do you think the most likely reason for this is?
Yeah, it's true. There has been, and there's been a lot of changes, and I'll start with the original theory that this was predicted, that as climate change was going to happen, the effect of what's called a gas leakage, which is the Indian Ocean current coming across onto the Atlantic side, was due to increase as a result of global warming. And that was supposedly going to shift species further east. That's a theory from, I forget the paper, but from a paper in, I think, South African Journal of Marine Science, before it was African Journal of Marine Science. And climate change is happening, and these changes are happening. But there's more to it than that in this drop-off happening so quickly. There's also been reports of a lot of fishing happening offshore that could be taking off smaller species of sharks, even some white sharks, although the really big ones don't tend to get caught so much. So it's probably not a direct effect, but it could be affecting their prey resources, the non-seal prey resources. But another huge thing, which some people argue over, but there's a huge impact in 2 killer whales that have arrived in this system, and those killer whales were not present when this data was collected, and those earlier studies, those killer whales are never there. They're very distinct. They've got bent fins, one to the left and one to the right. So one's called port and one's called starboard. And we know, and I've examined white sharks that have been killed by these 2 killer whales. And they've been in False Bay and in Hans Bay. They were seen in Mossel Bay once or twice, but they really have zoomed in. And those hotspots that I showed you from the Hans Bay area, they know them. They go straight to them because they know good chance of finding your prey. Just like the white sharks know there's a good chance of finding seals there, these killer whales know there's a good chance of finding white sharks in those hotspots, and they've killed quite a few. But a white shark's carcass will sink, so we won't be able to get it on most occasions. But it wasn't even a week, in about 5 days, when I was the last time I went to Hans Bay in 2017, we got 3 carcasses from that small area. One was a 4.8 meter female, one was a 4 meter male, 3.8 meter male, and one was about 3.5 meter, also a male. So that is an example of a predator that's newly arrived in the area, and it's displacing them. I mean, a white shark will have no chance against an adult killer whale on its own, yet alone 2 of them. So there's definitely been an impact of white sharks. And False Bay, I don't know False Bay as much, and I know that some people do agree and don't agree with that from False Bay, but I know Hans Bay very well, and I know that there's an effect of them there, and I've examined their carcasses. So I think that's been a huge thing. There still is occasionally a shark or 2 in False Bay, and there's still a few that come back to Hans Bay. And they tend to come and go, and it's not, there's not really many around Dyer Island. It's very rare to see one there at the moment. But when one dies, it's not necessarily that they've all been killed, but when one dies, there's a way that the sharks know that's happened, and then they move out of the area. So you'll get 1 or 2, 3 killed in a short space of time. The rest of the sharks will leave that area, and it can take a number of weeks or months before they come back. And that's been proven from my colleague, my supervisor, Sal, in California, where they've had some big killer whales. Sometimes they will kill a white shark, and when they do, the rest leave. So I think that's a very long answer. Sorry about that. That was Robin. But yeah, there's a growing body of literature on it, and it's but watch this space. I'm not an author that's currently working on that, but I know that there are. And watch the space, because there should be some more research.
All right. Anybody else? Last questions?
I've got, it's a private one from Mitch to me. Mitch has asked the same kind of question. So that was, I think, Mitch, I think I've covered yours with Robin's. That's what I think. Was it? Oh, and thank you, Robin, for answering that. Yeah. So yeah,
I have a question on how you feel. I know South Africa is very protective of white sharks. You know, the sharks leave, maybe they go up the Mozambican Channel, get close to Madagascar. Like globally, how do you feel the attitudes are? Are we making progress in global protection?
I think we're making progress. I think the right steps are being made. More species are getting protection from CITES, but we're kind of at a critical step. I was actually involved in, we put a lot of satellite tags on the white sharks in Hans Bay, False Bay, and Mossel Bay, and some of the other spots 1 year towards the end of my time living in South Africa. And that study went into a global study of shark tracking. And what it showed is there's a huge overlap of industrial fishing, particularly in offshore areas with shark hotspots. So a lot of sharks are still getting caught by longlining, probably the biggest threat. But industrial fishing is having a big impact on shark populations across the world. And I think we're at a critical stage where we know that now, and we need to use that information to try and enforce some kind of policy changes in high seas. Would be the first place I would look, high seas, and trying to reduce the amount of catch. From a perspective of conservation, I think you often hear these in newspapers, usually, like hype stories about, oh, there's more sharks, oh, there's more sharks, oh, it's a problem. But they don't usually account for the fact that there's more of us by the water, and we have smartphones, and we have better boats, and we have better spearfishing equipment. We're in the water for a lot longer. And a lot of these sharks are being displaced from other areas too, which is something that's also not accounted for, or drawn in. Either less fish in one area or more fish in another, and more seals in another area. And so we have to I think twice when we see the news headlines that even some of our research gets covered by, and try and be as ethical as possible in the way that we describe what's going on. There are problems. Not every shark paper has to be about conservation, but it's a pressing concern, and we do really need to make sure it's covered in our research conservation status.
Well, we've got lots of thanks, lots of thank yous. I think people enjoyed your talk.
Yeah, thanks very much, guys.
Geeking out with sharks. So I think we're coming to a close. So thanks everybody, and thank you so much, Ollie, for taking your time to be part of on a Friday.
Yeah, no worries. And yeah, you guys can. My Twitter handle is Jewell Research, so you can follow me on there. I was also going to send you Ed's, just paste that, I think I copied it. Yeah, this is Ed's story on the kelp. You can, oh, hang on, I've just replied that to Mitch. That was supposed to go to all of you, sorry, to everyone. That's Ed's website. We did a little bit of blog on this work. Yeah.
I'm sorry, what's your Twitter handle again?
At Jewell Research. I guess I could put a link to that in some way.
Yeah, let us follow all the new sharkies.
Yeah, sorry, I should be more prepared for these things. But as we're all in a thread, I just type it in.
And then see all the new stuff you're into, yeah?
Yeah, exactly. Twitter.com/research. That should work. If it doesn't, put it in Google, and then that might also link you to it. But yeah, there, people have ResearchGate, just my name on ResearchGate.
And if you Google your name and then go to Google Videos, all sorts of like news segments, footage of, if you guys want to watch the sharks going through the kelp forest, like video after video. Yeah,
there's some cool stuff also through the Island Conservation Trust as well. They put up a lot of videos.
Okay, well, I think that's good for us. Thank you again so much. Thanks everybody who tuned in, and I don't know, stay safe, stay home. Hopefully,
good luck for everyone.
Get out into the ocean soon. Start doing more sharky stuff.
Yeah, definitely.
All right. Thanks again. See you guys.
Cool. Thank you very much. Stay safe, everyone.